So now we're going to write the code for breadth first search. So we're going to bring up our tree like this. I'll shrink it down to the corner, and then we'll begin our method. So I want to point out that this is a method in the binary search tree class. So this is not a separate function. So that's why we have the self keyword there. And then we have a few variables that we need to create. First, we'll say that current node is equal to self.root. I've highlighted that in green on the tree there. And then we're going to need a queue. I'm going to implement this as a list. So if you'll recall from when we created the queue data structure, a list is not the ideal way to implement a queue from a big O perspective. But the reason I chose it here is everyone by this point in the course is very familiar with lists. So I want to use what's most familiar here so we can focus in on the mechanics of creating the breadth first search. So we'll bring in the queue here. And then the other thing we need to create is a results list. I'll bring that in like this. And then we need to take that current node and put it into the queue like this. We'll say queue.append current node. So remember, this is the entire node, the value and left and right. So then I'm going to represent that node that we put in the queue like this as a blue number. So we know that that's the entire node, not just the value. And it's very important that you put this node in the queue before you start your while loop, because the while loop is going to run as long as the length of the queue is greater than 0. In other words, it's going to run until the queue is empty. If you don't put the first node in there, the while loop will never run because it will start out by being empty. So let's focus in on the while loop and build this part out. So the first thing we're going to do is set that variable current node to be equal to the first item in the queue. And remember, this is the value and left and right. So first, let's do something with the value. We'll say results.append current node.value. So we're not putting the entire node in there. It's just the dot value portion. So now let's look to the left of that node. We'll say if current node.left is not none. In other words, if there is a node to the left of the current node, then we're going to say queue.append current node.left. So we'll append the node to the left of the current node like this. And then we'll do the same thing on the right. If there's a node on the right, we're going to do queue.append the node on the right, which is the 76. So then we go up and run the while loop again. So these two lines here, as we move through this while loop and repeat this, I'm going to combine these. So we're going to pop that first item off, and then we're going to append the value into the results list. So then the 21, we're going to look to see if it has an item on the left. That's going to be the 18. We'll append that to the queue. And then the item on the right will append that. Now we run the while loop again, and we move the 76 down to the results, and we look to the left of the 76 and add the 52 to the queue. And then to the right of the 76, we append the 82. Now we run the while loop again, and now we have the 18. Now the 18 doesn't have anything on the left or on the right. Same is true for the 27 and the 52 and the 82. So now our queue is empty, and we were only running the while loop while the queue had a length greater than 0. So we're done with this. We're done with the while loop. The only thing left to do is return that results list. So let's look at this in with the rest of our code like this. This is the entire method for breadth first search. And we'll look at this in a moment in VS Code. And when we do, we'll create this tree, and we'll expect to see this list returned. Okay, so let's go take a look at this in VS Code. Okay, so there is our method there for breadth first search. I'm going to scroll to the top here, and I want to emphasize that this is a method inside of our binary search tree class. So I'm going to scroll back down here, and there's our method again. And I'll scroll up a little more. This is going to create that binary search tree that we just saw, and we're going to print mytree.bfs, breadth first search, and we would expect it to return this list here. So I'll run this, and you can see that this list up here matches this list down here. And then something else I wanted to point out here is that list that was returned is in the same order that we created the tree here. Okay, and that is our method for breadth first search.